Hi student, in this video we are going to learn about the minimization of deterministic finite automata. Myself, Dr. Dhrampal Singh, Associate Professor and HOD of the Department of Computer Science and Engineering, JIS College of Engineering. Your paper name is Formal Language and Automata Theory and paper code CS403. Okay, so as you are aware about the prerequisites like we require digital logic, computer organization, computer fundamentals, and these are the course outcomes of your subject, and these are the mapping of CO and PO from course to the program outcomes. These are the course content. Now today lecture is the minimization of DFA. So why we can go for the minimization? Any need? How we can minimize the DFA there? So as you know that already in case of finite state machine minimization, I have given the concept. If number of states in a automata is less, we require the less design of transition function. I've also given the example, if some task is there, if this task is performed by the 10 person and same task is equivalent is performed by the 5 person, so which one is the optimal? We always go for the 5 person. So same thing is applicable. If DFA is given there, we have to try to minimize the DFA. So before that, we require the two concepts. When I can say that two states are equivalent or two states are not equivalent. Okay, what is the meaning of K equivalent? So already you can get some idea from your finite state machine. Here the idea is same, but here we are dealing the thing with the DFA. Okay. So now you can see that it says that two states Q1 and Q are equivalent, denoted by this way, if and only if both this one are final state and both of them are non-final state for all value of x belongs to this. What is the meaning of this one? Suppose if I draw this figure, suppose. Okay, you can see this figure. Okay. So as you know that this is the initial state and make this one is the final state. Okay. Concentric circle is the final state. Now you can see that if I ask, tell me whether Q0 and Q1 are equivalent for the input 0. Tell me. So you have to check that. After taking the 0, it will be go to the Q1, means Q0 taking the 0, it go to the Q1. Okay, and Q1 taking the 0, it go to the Q2. Q1 taking the 0, it go to the. So what I can see here, for the input 0 0, I am getting one is a non-final NF and second one is the final, because Q2 is the final state. Okay. So here what is saying that two states are equivalent if both the are final state. It is saying that after reaching these two states must be the final or these two states must be the non-final. But here what we are getting? Here we are getting that one is final and second one is the, sorry, one is final, this one, and one is the non-final. So they are not equivalent. Keep in mind, they are not equivalent. Because we know that when two persons are equivalent, if I apply the same input, they produce the same output. Suppose if I apply one, it is producing X and second one producing Y. So they are not equivalent. So here equivalent means what I can say. Equivalent is when apply your input sequence, we have to see that whether we are going for the same final state or both of them going for the same non-final, not same, means non-final state. then I can say they are equivalent there. But here for the 0, we have seen that one is the non-final, second one final, so it will be not acceptable. Now you have to check for 1, you can see Q01. Q01, we are going for Q1. See here, Q01, we are going for the Q1. And Q1, again 1, we are going to the same state. So here what I can getting? Both of them, they are the non-final. So they are equivalent for the input 1, but they are not equivalent for the input 0. So I hope that this idea is clear. What is the meaning of equivalent of the state? Keep in mind that equivalent of state means after applying the input X, you can say input must be same there, okay? Input X, both of them are final state or both of them are non-final state, then they are equivalent. Okay, so two states are K equivalent if length of the string is greater than and equal to K. Suppose if length of the string is 2, I can say they are 2 equivalent. If length of the string is 3, I can say they are 3 equivalent. So I hope that this idea is clear to you. Now we are going for the minimization of automata. Okay. What is the meaning of minimization of automata? So here I can see that Q0 is your initial state and Q2 is your final state, because here we can see arrow symbol is given here and concentric party, so circle is there. So I can assume this is the initial state and this is the final state. Okay. So here we have to calculate pi 0. Keep in mind, everyone. Means 0 equivalent. So 0 equivalent is saying that suppose without any input, non-final state will be belongs to one set or final state will be belongs to the one set, like this one. Here Q2 is the final state, it will become to the one set, and remaining state like Q0, Q1, Q3, Q4, Q5, Q6 and Q7, they belong to the your other state there, because they are non-final and this is a final. Okay, so this is the meaning of pi 0 means keep in mind that here all final, suppose here assume that there are two final states are there like Q2 and Q5, so they will come to the one set and remaining one to the one set. Okay, so this is the way to design the pi 0. Now go for the pi 1. When we go for the pi 1, so we have to compare equivalent. So Q2 is alone, so there is no required to compare it because it is alone there, so I can write as it is. Now you have to compare between Q0 and Q1, whether they are equivalent or not. Okay, so you have to check that whether the element of these two, means after reaching, they are belongs to same set of pi 0 or not. Okay, now check Q0, Q1. Taking the 0, it is going to Q1 and Q6. Q1 and Q6 belongs to this set. You can see Q1 here, Q6 here. So no problem for the 0. For 1, you can see Q5 and Q2. I can see Q5 here and Q2 here. So they belongs to different set. If different set they belong, I can say they are not equivalent. So I can put cross here. Keep in mind here cross. Okay, now check Q0 with the Q3. Q0 with the Q3. Q1, Q0. Both are here, no problem. Again, we are getting Q2 and Q5. Q5 is this set, Q2 in this set. Again, they are different, so I can cross here. They are not equivalent with the Q. Now Q0 with Q4, check it. Q0 with Q4. Here I can getting Q1, here I am getting Q7. Q1 and Q7 both belong to the same set, no problem. Here I am getting Q5, here I am getting again Q5. Q5 is a single element and belongs to the same set. So it has no problem. So I can say it is correct. Means Q0, Q4 are the equivalent. Similarly, you have to check for Q5. Here I can see it is a Q2 and here it is Q0. Again, Q2 belongs to this, Q0 belongs to this. So they are not equivalent. All I am checking with the Q0. Okay. Now you can check Q6. To check the Q6, You can get 6 here, you can get 1 here. So both are belongs to this set. Okay. Now here Q6, here Q5. Again, they are belongs to same set, no problem. So they are equivalent with the Q0, Q6. Similarly, Q7, you can check that. Here I am getting 5, here getting 1. For 0, it is not problem, same set. But here I am getting 2, here getting a 5 there. So it is create problem. So it is not equivalent. So what are the equivalent here? This one, this one, this one. So if they are equivalent, so I can write in the one set like Q0, Q4, and the Q6. After that, what are the remaining sets are there? 1, 3, 5, 7. So you have to check 1 with the 3. 1 with the 3 we have to check. So I am erasing something, okay, for the simplicity. Okay, now we have to check that the Q1 with the Q3. Okay. So what I can get here? Q1 with the Q3. You can see Q1 is the Q6 and Q3 is the Q2. Again, here it is one belongs to this set, one belongs to this set. So it is also Q3 is also not equivalent with the Q1. Now Q1 with the Q5 we have to check. Again it is the Q6 and here Q2 there. Again problem, one is this set. So it is also not equivalent with the Q1 there. Q1 with the Q7 you can check. It is a 5, it is a 6. So both belong to one set. Here you can say it is a Q2. Here also it is a Q2. So both belongs to this same. So I can say this is the equivalent with the your Q1 there. So I can write Q1, Q7. Now what are the remaining thing? Q3 and Q5. Check Q3, Q5 are equivalent or not. Q3 you can say Q2. Here I can say Q2. So both belongs to same set here. Q5 and again it is the value of the your Q6 there. So both are the same set. So it is not getting any problem. So I can write Q3, Q7. Okay. So now after this one, we have to calculate the pi 2. What is the value of pi 2? When you go for the pi 2, we have to consider the set of the pi 1. Okay, we have to consider the set of the pi 1, not the pi 0. We have to check same thing, whether these Q0, Q4 elements belong to same set or not, of pi 1, not the pi 0. Now check that Q2 is a single element, not required to divide. We can write as it is, because pair comparison only occur between two sets. Okay. Now you have to check Q0 with the Q4. Check Q0 is the Q1 and Q4 is the Q7. Now they are belongs to the same set of the pi 1. Okay, for the 0. Q0, Q4 for the Q1, Q5, Q5. Q5 is the always the, sorry, this will be the 5 most probably. Okay, sorry. Okay, Q3, Q5. So this is the equal here. Okay. Okay. So how we can go for the your checking here? So here you can see that Q0, Q4 not creating any problem. If I say it is the Q1, Q4, it is a Q7. Both are in same set. And Q4, it is a Q5 and it is a Q5. Both in the same set. So it is not getting any problem. So it is okay. Now Q0 with the Q6, you can check. I'm getting Q6 here and getting Q1 here. Now you can see. Here I'm getting Q1. Here we are getting the Q6. Q1 belongs to this set. Q6 belongs to this set. So they are differ. If they are differ, I can say it is not equivalent, and we have to divide the group. So your group will be divided like this one. Q0, Q4, Q6 is alone now. Okay. Now check Q1 with the Q7. Q1 belongs to Q6, Q7 belongs to. So I can erase this part, it is a better. So now you can check Q1 and Q7. Q1 belongs to Q6 and Q7 also belongs to the your Q6 there. So both are equivalent. Q6, Q6, I can say that the both are the same set. Q6, Q6 is the same, obviously single set is there. Now the for the input it is the Q2 and it is the Q2. Again it is the same set. So it is not get any problem. So I can write Q1, Q7 as it is. Now for this Q3 and Q5, again check it. Q3, Q2 and Q5 is the Q2. So again it is the same set of pi 1. Now Q3 is the Q6 and Q5 is also the Q6. So again it is the same set. So not get any problem. So there will be the no changes like this one. It will be the Q3 and Q5. So after this one we have to calculate the pi 3. Okay. We have to calculate the pi 3. Again you have to write the Q2 as it is alone. Again you have to check the Q0, Q4. So you have to take the set of pi 2, not the pi 1 here. Check Q0, Q4. Q0 is the Q1, Q4 is the Q7. Again they belong to same set. Yes, here I can see same set. It is the Q5 and the Q4 is also the Q5. Again it is same set. So again they are not divided. They are as it is. So I can write it is as a Q4. Now Q6 is a single element, not required to compare. We have to write as it is. Q1, Q7 again we have to check. Q1 is the Q6, Q7 is the Q6. So Q6 obviously is the single set of the pi 2, not get any problem. Again for the value of this one, it is the Q4 and it is the your Q2 and Q2, Q4 again belongs to same set. It is again not getting problem. So I can write Q1, Q7 as it is. There will be the no changes. This division is not possible. Q3, Q5 again check. Here it is Q2 and Q5 again Q2. So it's same set here, no problem. For the one we can check it is the Q6 and then the Q3, it is also the Q6. So again it is not possible any changes here. Okay. So I can write the Q3 and Q4. So now you can see there is no changes between pi 2 to pi 3. You can see all the set are common. You can see whatever the sets here, whatever the sets here. If this means from the previous to next, there is no changes in a set of state. So we can stop here. After stopping, we can see whatever we have done, we are getting this figure. You can see here, whatever we have done, like Q2, Q0, Q6, Q6, Q1, Q7, Q3, Q4, whatever the things here there, we are getting here. You can see. So we can write all the things in a single state in this way. Also, we can give like A, B, C for the simplicity. If you want to give the name, you can give as it is. It will not give the problem. Okay, you can give the name just like this, A, B, C, D, E. Okay, so you can say Q3 and Q4. Sorry, Q0 and Q4. We have to make that Q0 and Q4. What is the value for 0? Q1 and Q7. So what name I have given Q1 and Q7 as the B. So I can write here B. Q0, Q4 for taking the one where it is going. Q5, Q5. So Q5 name is, Q5 belongs to this set. You can see. I can say it is the D. So similarly for the every input, suppose Q1, Q7. Okay, check that Q1, Q7. Q1, Q7 you can check Q6, Q6. Okay, Q2, Q2. So Q2 is represented by which value? So Q2 represented by the C. So here C will become, and Q0, Q4 represented by the your A. So A will become. Sorry. Here C will be here, and only we are getting the 6 if I apply the value of the this one Q1 and Q7. Q1 getting 6, Q7 also getting the 6, means they're getting the only the this state E. So I can write the E. Or also you can write in this way, it will not be a problem. So what I can say that 1, 2, 3, 4, 5. Here we have the 8 states. Now after minimization, we got the 5 states. So this is the way to minimize the automator there. First, find the pi 0. After, when you go for the pi 1, check that whether the element belong to same set or not. So when you find the pi 0, all final state will be the single set, or non-final will be the single set. After that, we compare the pair, whether they are compatible with equivalent of each other or not. If they say they belongs to one set, if not, we can divide. When you go for the pi 1, consider the set of pi 0. When you go pi 2, consider the set of pi 1. When you go for pi 3, consider the set of pi. This process will continue when there is no change from the previous. So after that, we can also draw the diagram in phase of your transitions system. It is very easy to draw. We know that if I make this is the one state, if this is a one state, this is a one state, this is a one state. So I know that Q0, Q4 taking the 0, it is going to this way. So I can write Q0, Q4 taking the 0 is going to the Q1, Q7. And taking the 1, it is going Q3, Q5. Q3, Q5. So same set they have drawn here, you can see. So I hope that it is clear to you. Okay. So thank you, my dear student.